Welcome to the Azure Thursday. I'm Roeland. Together with Luke, I'll be hosting tonight's event. So welcome, Luke.
Hi, thanks. Good evening, everybody.
Good evening. For our first session, in just a moment, Yusuf will show us the way in monitoring and debugging distributed systems in Azure. I'm being a software developer myself. I'm really looking forward to that one. Really excited to hear about his experiences. And for the second session, we'll start at 8 p.m. sharp with Stefan and Jordi. We'll be introducing Windows Virtual Desktop to us and how to use Azure DevOps for the image and software management. I have not used for Windows Virtual Desktop myself. Have you already tried it, Luke?
No,
experienced in?
Me neither. So
it's new for you as well.
Also new for me, yeah.
Well, then it's very good that they're going to show us the introduction version of it.
Yeah.
Because it all looks very promising. I only saw the stuff that's there online on it. So really looking forward to that one as well. But our first speaker is Yusuf, who's a software developer at Capgemini, and he's already waiting in the lobby, I think. Yusuf, are you there? Are you able to join us?
Yes.
You are. Welcome, Yusuf.
Hey, welcome.
Thanks, guys.
So very good to have you here. I'll not try to steal your entire introduction sheet, as I warned before. I usually do that, so I'm not going to do that this time and let you just introduce yourself during your presentation. But I saw on your LinkedIn page you worked on some very interesting projects as a software developer, including some Angular projects. What is your favorite technology stack? What is your go-to technology stack when you're developing software?
That's a good question. I used to be more a front-end guy, so I liked Angular, but lately I've been more into the way React works, because it gives more flexibility. And but not all-time favorite, I would say, is Vue, because the simplicity and the whole infrastructure and the community around it makes it like, I think, my favorite framework to work with.
Very cool. So you know almost every big framework out there for the front end.
Not in depth, but I built small applications with it, and at a certain point, there's a lot of style being repeated. So it makes it, when you understand the concepts, it makes it easy to switch.
Of course, yeah.
Especially within React and Vue, it's almost kind of the same. With Angular, it was for me, it was a steep learning curve, but at the end, I mastered that dragon.
Very cool. Well, then maybe we should have another session on your experiences and comparing those, because I'm really always struggling which one to choose. But that's probably not Azure related, so we'll have to do that another time probably.
Sounds good.
But well, Luke, do you have any questions for Yusuf, or are we just ready for the session?
No, just ready for a session. Yeah.
Very cool. Well, Yusuf, the floor is yours. Best of luck. And
good luck.
Any questions, post them in the chat for our viewers, and we'll relay them to Yusuf at the end of the session. We have some Q&A.
Thanks, guys. I think I'll start my presentation. So welcome, everyone, to my presentation about monitoring, debugging distributed systems within Azure. And before I start my presentation, let me first tell you something about myself. My name is Yusuf. I'm a software engineer at Capgemini for the last 3 years now. My hobbies are watching movies, specifically thrillers. I also like traveling. That's something that I haven't been able to do lately, but hopefully this summer that will change. If you have any questions or queries about the things I do or the project work, then you can find out more about on my website, yusuf.nl, or email me if you have something interesting. So let's start with the presentation. Before we go in depth about monitoring debugging, let me first tell you about distributed systems. As you can see in the picture, on the right you will see a distributed system. As the name implies, it means a system that's been broken up into several components. And this is different compared to a more traditional monolith. That's a picture on the diagram on the left. And it's an architecture that has proven it has benefits. One of those are, for example, maintainability. when you have a new developer joining the team, it makes it easier for the developer to tackle one code base at a time instead of being overwhelmed with the whole code base at once. And also the repositories become smaller and easier to maintain. If a certain component notices a lot of traffic, you can scale up that component specifically, and also makes it possible for your application to scale horizontally. So that's a great improvement. Instead of with a singleton, you need to deploy several same instances of the whole application. Instead of only the components are under heavy load. And if a certain component has issues or turns off or whatever, then it will impact the whole system going down compared to that may occur within a singleton. But a distributed system doesn't only have benefits, it also has some downsides. I think one of the big ones are monitoring. Because a request can go through several components, it makes it hard to track the performance and the whole transaction to each component it goes through. And also, if something goes wrong during that request through the several components, it's hard to pinpoint where it went wrong or where it went down. So to tackle those issues on Azure, we have Azure Monitor, and Azure Monitor is an application within Azure, is a service of Azure, and it makes it possible as a service that helps you increase the performance and availability of your application services. It does so by collecting and analyzing and acting on the telemetry from your applications and cloud environments. So if you look at the picture on the left, you will see the different resources that may create the telemetry, and all those items will be stored within telemetry and buckets. So all the logs of telemetry will be stored there. And on the right, you'll see several components within Azure Monitor that will act on the telemetry items. As you can see, it's quite Azure Monitor has a lot of features, and in this presentation, I'll only be looking at two features, specifically the application insights. And within that, we'll be looking at the application map, the search, the Snapshot Debugger, and within alerts, we'll be looking into the automatic alerts. So first, let's start with monitoring. Application map is a feature within application insights, and it visualizes the topology of your distributed system. And what that means is you'll see in one overview all the components that are part of your distributed system. And a component is an independently deployable part of your distributed microservices or application. So this can be, for example, an API or a function. And because you can easily see in one view the whole application, it makes it easy for you to spot performance bottlenecks and failure hotspots. Because for each component, you can see metadata about how many requests came in, how many of those requests failed, how long each request took. And it tracks all it visualizes all the components because it looks at the HTTP traffic. But it may occur that certain dependencies are not being visualized. For example, a component that's not deployed within Azure, for example, an SAP dependency. And in that case, you can use the Application Insights SDK to add custom telemetry items within code. And it's something I will show you later on in the demo. So search is also a feature within Application Insights, and it's used for finding individual telemetry items. With the previous one, it uses data from all telemetry items that went into the buckets, and here you can find individual items. And this is useful, for example, if you're searching for a specific log or an exception that occurred within your stack trace, within your application. And yeah, this can be quite expensive at a certain point because the amount of telemetry being saved. And to solve the issue, Microsoft applies sampling. Sampling is the recommended way to reduce telemetry traffic, data cost, and storage cost, while still preserving a statistically correct analysis of the application data. You can search for the items within the portal, but there's also an integration within Visual Studio that makes it possible for you to search the items within the editor. Alerts. Yeah. Alerts is a component that can be used for when you want to be proactively notified of irregular behavior. The previous two features were mostly looking into monitoring a situation that already occurred, something you want to be proactively notified. And the way it works is you first create an alert rule, and within an alert rule, you specify the resource you want to monitor. So this can be, for example, the application service. And then you create criteria that needs to be met. This can be, for example, an X amount of traffic that comes in over a certain period, for example, 5 minutes, and it will in the interval of each 1 minute. So it will look in that 5-minute period if it matches that at least, for example, 20 requests came in, and it is above the threshold. Then an action group will be notified. An action group will kick off, and this can be an email being sent around to a group. And when the email has been sent and the alert has been set, then it will be set to the status of new, and then you will need to monitor the condition. So you need to acknowledge the setting and change it later on to the correct condition, and to show you that you've processed the alert. So that's the monitoring part. Now let's head over to the debugging part. Yeah, within Debugger, we can use Snapshot Debugger, and this is featured within Application Insights. And this makes it possible for you to monitor exceptions that occur in live applications. And Snapshot Debugger collects the snapshots on your top shown exceptions, so that you have information you need to diagnose the issues in production. And as the name implies, it will create, you can see in the snapshot the state of the source code and variables the moment the exception was thrown. And this makes it easy for you to pinpoint what is going wrong instead of you need to go through all the logs the traditional way. There's also integration with Azure Studio that makes it possible for you to add custom snapshots in certain locations where you want to have extra snapshot when one is not enough. Remote debugging is kind of similar to the way you work with local debugging, but instead you will be attaching to a process of a live application. So that way you can add the debugging. You can debug your live application. To do that, first you will need to deploy your application using the debug configuration, and it is recommended that you don't do this to applications in production, because it can impact the users that are using the application in that environment. So it's recommended you remote debug an application that's set, for example, in a staging slot or in a staging environment instead of a production environment. So all the theories are very interesting, but I think people are more interested in the demo. So let's talk about that part. To show you how monitoring debugging works, I created small demo applications to highlight the distributed system. The application consists of an API, and with an API you will place orders on a service bus within a queue. And there's a function also listening to the queue, and it will pick up any new message and process that. It will perform some business logic and then write the results to storage, to a table storage. The API then can retrieve the results from the table storage. So in our case, our components, our deployable components, are the API and the function, and we have two dependencies: the service bus and the table storage. But before we can start monitoring and debugging our application, we'll first need to create the application insight resource. That's the resource we'll be using to monitor and debug. And we need to deploy our applications, the API and the function, to Azure. And then in Azure, we need for those two deployed resources to enable the application insights. So first, let's head over to the portal, start creating the application insights resource. So in the portal, we will go to application insights, And then, as you can see, I already created an application inside this resource, but I can show you how I created one, just for the sake of saving time. You would assign to a resource group if you already have one. Otherwise, you need to create a new one. As you can see, I already have one. And then give it a name. And then assign to a region. And in the resource mode, it is recommended you use the workspace-based, because that way you can have all the benefits of the log analytics workspace, and also because Classic has been deprecated. And that's it. I think after that, then you can review it and create it. But I won't be doing that step because I already have an application insights. And then if it's been created, then you can go to the resource, and as you can see, it will look like this. Now let's head over to the code. Now we're deploying our API and our function. So API is just a traditional ASP.NET Core application. And there's several ways to deploy application to Azure. For the sake of simplicity, I'll be using the Visual Studio to publish our application to the API, to the Azure, sorry. So you can just right-click on the project, select Publish, and then let me zoom in. Okay, it's a little bit readable, but then first you'll need to create a published profile. I already have a published profile, so I can show you how a new one looks. So you would then select Azure. From there, you would select Azure App Service, and then the Windows variant, because we need some features that aren't available in the Linux version. And then here you would select, you would create a new app service if you already have one. I already deployed this, I already have one, but it will look like this. So you can create all the resources you need in Azure using Visual Studio as well. So same as before, you need to select a resource group and an app service plan to host it in. If you don't have one, you can create a new one, as you can see. After that, after you've been through all the steps, you will then have a new published profile. And then the only step you'll need left is setting the service dependencies. And this is needed so that when you publish your API, it already has a connection to the table storage and the application side. So the dependencies we have from here. And the moment you set these service dependencies, you'll also set the connected services to these two resources. And this is useful because when this has been set, the application insights will mean that within Visual Studio, we'll be using the application insights not locally, but the one you will have in Azure. And the great benefit of having that is then you can see here at the top what the application insights, telemetry data that's of this endpoint specifically. So as you can see, for example, details page has this amount of information about how it's performing in the cloud. And now we will do the same for the function. And the function isn't that different compared to the API, the ASP.NET Core application. You'll perform the same steps to deploy it or publish it to Azure. So again, you'll right-click the application, select Publish. Maybe have it from here, and then you will see the same window. And then I already have one, but just the steps are similar, where you go to the steps again. And from there, you'll go through it again. As you can see, I have here one error. And the cool thing about Azure is you can just, if you have error, you can just remove this, and then it will remove all the profiles. And you can just configure it again. And when you configure it, you can see, because I'm already logged in with Visual Studio using my Azure account, it will automatically find our application insight resource I already have. So I can select it, press next. It will set everything correctly. Next, and then it will also install the dependencies that are needed and configure it correctly. And that's it. Close. And now, because it's now set correctly, it also will connect here correctly. Oh, it didn't. And here you can perform the same step 7. Next, and finish. Close. So that's the and normally you would deploy this, but already have published our application, the API and the function to Azure. So I'll be showing that part now. So if it's done correctly, if I would go to App Services, you would see the API and the function. And for the sake of time, I've already done this before. So now the last step is enabling the application insights on these 2 resources. So you click for it. I'll start with the API first, and then if you go a little bit down within settings, you'll need to click on application insights. And normally this will be, when you deploy it for the first time, it will be disabled. Depending, you do the same way you deploy this as I did, and then it's just a matter of switching a button. You will have the integration within your API and application insights. As you can see, it's connected to our application insights resource that I have created not today, but a while back. So that's the cool thing about Azure is that it makes it easier to connect all the resources that are already deployed within Azure. And further down more, you can even configure it more when needed. For example, we'll be using Snapshot Debugger later on, and also you can maybe select like if you want to show the local variables what exception is thrown. So that's very cool, how easy it is to integrate an app service and application insights together. And within function, it's similar. So select the function, and then from there, you will need to go to the application insights and just enable it. And as you can see, it's also connected to the same application insights resource as the one the API uses. So this saves a lot of time, but it also makes the integration between all the resources much easier. So if I'll go back to the function, there's also two things I want to show. For example, if you look here, we have here a class called Telemetry Initializer, and this implements an interface from the Application Insights SDK, because with this interface, it makes it easier for you to override the default names of your deployed resource. Because this way, you give a custom name to the role name or role instance in this case, and this is very useful because the default name you'll get sometimes maybe kind of confusing or not clear about which resource it is, and if you override it with a custom name, it just makes it easy for you to see what it is. And also, when we go to function, earlier within application map, I was talking about also custom telemetry. So out of the box, application map will show you everything, but with this telemetry items, you can add also custom telemetry. So you just create a dependency for this case, or I call it a dependency, and a fictional component I also want to show later on in application map. So now that we have deployed all the resources that are necessary, let's start monitoring it. And before we can monitor, we will need to generate some traffic. So I'll start first by adding an order. As you can see, this base URI refers to our the address in Azure. So what this does is it will use the API to put a message on the service bus, and the function will pick up that order later. And now we'll retrieve the details. As you can see, it gave me a 500. So let's try another store. So let's try to get the details from store with ID number 1 instead of 11. Okay, so that worked. Okay, so now I also made an endpoint just to simulate a bunch of random orders. For example, the size of 10 is fine. So let's create 10 random orders with 10 random IDs. Cool. Now we've done that, let's head back to the portal and see how that let's monitor the behavior I've created. So we will first go to the application insights, and now let's go to the application map. So and I only want to see the last 30 minutes. Yeah, so sometimes it may be kind of difficult to see because I can't organize, but what you're seeing here actually is, as you can see, the custom names. So the big circles are our components, our deployable components. So in this case, you can see the custom name I passed to the function and the API, the orders API. And if we zoom in a little, maybe I'll refresh. Come on, show me a little bit more metadata. Yeah, it takes a while. While this loads, okay. I can show you, like, for example, also the dependencies has. So it looks similar to the architecture diagram I showed earlier. So we have here the API, and the API will use the service bus SDK, and it will put a message on the SDK. So that's the line what we're seeing here, and that will then we have a worker that also will pick up the message and then write the results to the table storage. And we also have here the custom telemetry I've shown earlier, the store.com within the function. And the cool thing about application map is it shows you very easily, like how the requests were performing. For example, you could see here the green highlights how many requests were successful, and here how many failed. And if you click on each component, you can see more information about a certain component. So if I go to compute, it will show you which resources this is about. So this is about the app service we created earlier. And if you go, for example, to failing requests, investigate failures, then you can see here the 500 error we got earlier, and also which operation that was. So let's click on this, and let's click on details. As you can see here, so that was the request I performed. Store with number ID 11, and it failed, and it also got a no reference exception. You can also see which dependency it tried to access, and it tried to access the table storage within this table store order, and it returned 404. So that already indicates that that certain item wasn't present in the table storage. So that's the great thing about application map. It looks very similar to if it's done correctly, it looks very similar to the architecture you've created earlier. So now let's go to the search, and here we can find a certain telemetry item we want to find. So for example, let's say I want to find the tail block field request telemetry item. So first you'll select the time frame, and from here you can just keep narrowing down. So now it will show you all the items of the last 24 hours. But if I say only want the last 30 minutes, that it already like limits the amount of results I get back. And you can just keep on filtering till you find the certain log or telemetry item you're searching for. So for example, I only want things that are with the cloud role name of the custom name I had earlier, for example, API. And from here, example, let's only find successful request. So this way we can exactly find the failed request of this certain resource. And as you can see, it will bring it back to the same place. So there are several ways to get information about requests that have failed, but also one that are, for example, are successful. So for example, the simulate order cut was done successful. And let's try another one. Yeah, so this is, for example, when I try to read the details of store number 1 that was successful. And you can even see all the telemetry items that belong to it. So we could find an item from store, and then it will pass. Now let's back to the application insights, and let's go to alerts. And alerts is a feature that you can use, like as I told earlier, to be proactively notified. I have a total of 3 alerts, and if you want to create an alert, first you'll need, as you can see, this has been one has already been fired, and let's create a new alert rule. So normally, like you would create. First, you would select the resource. So I want to be notified everything within this code. So for example, everything that's being monitored within my application insights. You can add a condition, and this can be anything. You can make it as matching for your use case as much as possible. Instead of creating a new one, let's look into the one I've created earlier. So let me see my alert. So why did this alert fire? So as you can see, I put a threshold on that if there are more requests coming in that are above 30, then I will need to be notified. So the threshold is 30, and the actual amount was 63. So that's why the amount of requests that came in this, everything was connected to application insights, it got triggered. And if you go through here, yeah, so this is the actual rule. And the cool thing about this is, like, it will show you the threshold. For example, 30 I put in, and you can see also the actual behavior at this moment. So it makes it easier for you to see, like, is 30 maybe too low? Because now I have 2 peaks that were around 165 and 63, so maybe 30 is a bit on the low side. So now, for example, if I put in 200, you can see how 200 compares to the actual situation that's going on. And you can also put in the granularity, like that it needs to be aggregate every minute, and the frequency of 1 minute, every 1 minute that needs to check. Normally you would just put a bigger time frame, but for the sake of this, I put it quite quick after each other. And after that, you'll need to create an application, an action group. I've chosen that the email that will be sent, and I can show you how the email looks like. So if it's done correctly, you will get a new email, and the email will look like this. As you can see, your Azure Monitor alert was resolved because I clicked early on the alert. And of course, when alert has been notified, you'll need to go back. I need to address the actual alert, maybe a bit too back. Because after you, like for example, I've noticed the behavior, you can explain that. You can just say, okay, I've acknowledged the situation and add a comment to it to explain. And this will all be saved, so it makes it easier for us to have a traceable log of all the alerts that have occurred. So that's the alerts part. Now let's look into debugging. For that, we need to go back to Application Insights. Now let's go to failures. And let's maybe do the last 30 minutes. While this loads, yeah, okay, it's done. So on the right, as you can see here, you have 81 operations, and for each, and also the amount of snapshots. And if you click on this, you can see the snapshot that Application Insights have made. So it takes a while to load the snapshot, but from here you can see the stack trace and how the code looks the moment the exception was thrown. And this is also, you can also download the snapshot and open it in Visual Studio, but it takes quite a while. So as you can see, the exception that has been thrown is a null reference, and you can also see the variables that were at that moment, and also the request that came into the function. As you can see, for example, table number 4. And this is something very useful if you don't want to go through the logs to see why something has failed. You can just go see the snapshot. And this is something you first need to enable on the Application Insight. So we enable this for the API, and within the function, you'll need to enable it using the host.json. So within the host.json, you'll need to add this configuration. Snapshot configuration is enabled true. That's the only thing you need to do for the function. For the API, you can enable this using the portal. And now let's look into the remote debugging. And remote debugging, yeah, it's quite similar to the local debugging, as I told earlier. So there's several ways. I always use these options. So if you select attach to process, and then from here you'll need to set the connection target, and this will be then the address of your deployed applications. So as you can see, this is where the application lives, and then you add the port 4024, and then the first time you may be asked to pass in the username and password, and that is something you can retrieve by getting the publish profile if you download that. So I also need to show you that first. Visual Studio isn't, come on, okay, that's fine. The Cloud Explorer isn't my favorite today, so yeah, the important thing to remember is like that you use for the first time you need to download the publish profile, and there you will find username and password you will need to pass in here. And when it's connected, then you'll see the processes that are available, and you'll need to select this one, the W3WP process, and then you can just attach. As you can see, we're connecting to that process on the live application. And there's no certain way to see if it's done connecting, but let's try getting the details of the store that caused the error earlier. Cool, yeah. So it hit the breakpoint because it was. It takes a while to load, but let's see. Yeah, cool. So as you can see now, it hit the breakpoint on a live application, and we can see. Let me close this one. Yeah, so we can now see the information about the variables. So for example, why did this fail earlier? As you can see, let me zoom in a little bit. So this is the result variable from our retrieve operation on the table storage. As you can see, the HTTP status code we got back is 404. So that would mean that result, that this variable probably is null. So as you can see, the variable store is null, and I'll try to access a property on this variable that is null. So that explains why it failed earlier. So now let's continue. Now let's try again. Yeah, so as you can see, it will say again the exception of no reference. So this is very useful for when you want to debug a certain issue that like occurs only in production, but not necessarily on your local environment. There is like a warning. This is not recommended on live production. But it makes it easier instead of like trying to mimic a certain situation on your local environment. Now let's head back to our presentation. Yeah, so in summary, let's summarize this part. So out of the box, you'll get a lot of cool things within Azure Monitor. It's just a matter of turning on and off certain features that you want to use. It also monitor all the dependencies you have within Azure. For example, the service bus and the table storage will already be available in the application map, and the components you are missing, you can supplement that with using the Application Insight SDK. Yeah, it works in a matter of like you'll need to collect all the telemetry you have, and you can analyze the all telemetry you have and then act upon it using the alerts. And if you look at the features within Azure Monitor, I only have shown you the application insights and the alerts, where there's so much more I haven't shown you this presentation, but trust me, there's so much more cool stuff available. I think that's my presentation about Azure Monitor debugging. Are there any questions?
Very cool. Yeah, there are a few questions, certainly. It was an amazing presentation. I really loved your demos, tying so many resources together and making it so transparent in application insights where the problem was. I also really love working with application insights myself for tracing production issues, and it makes our life so much easier, I think. So it was a very good presentation. We had a couple of questions. The first one is when you have external services, because you now showed us the internal Azure services.
Yes.
If you would have an external service that that won't expose any telemetry data, can you tell us a bit how that would look in the application map?
Yeah, I think it's possible for you. I think it's not possible. It's possible for you to show you the components that are external, but to actually monitor, for example, the performance, then, for example, the amount of requests that failed. There's some within the SDK. It may be possible, but you will need to set up more code around that, for example, because it won't track as much as telemetry, for example, with native Azure resources.
Or Azure, yeah, that's logical. And that's, I think, what you meant, because you said for Linux environments, there are less features that are measured, and that's probably the telemetry data from the system itself, which is not possible to measure all of it, which you can do on a Windows environment, right?
Correct.
Yeah. Yeah, so you would see for an external service, you would see the response times and the failures, and but you won't see the performance of it, only the core response values, which you get in return. So that's
for example, the Snapshot Debugger, it isn't available on all the types of APIs. Like, for example, I think it's not possible when you deploy your application within a container, because that behaves differently. So there are limitations about things I've shown in this presentation. that aren't applicable to all the types of API.
Of course. Well, there's so many powerful features in there, so I think there's something for everyone. You mentioned the Snapshot Debugger. I remember from the past, the good old days, that there was a maximum of snapshots you could store in Azure. Is that still the case? Are you limited to the number of snapshots you have?
I'm not sure what the service limits are, but I know that it's quite big, because you'll need to. I didn't do this demo in the Visual Studio because it takes a long time to get all the symbols. But yeah, you'll need to connect it to the table storage, and yeah, it gets quite big. And there's also a limit about how many snapshots you can make in a running application with a Visual Studio.
During the day. And it has to be triggered, I think the exception has to be triggered a couple of times, right? Before it actually makes a snapshot. So it.
Yeah, I made a conscious decision not to include in the presentation because I've noticed sometimes it didn't trigger to make the snapshot. So, and it takes quite long to get all the symbols to load within Visual Studio.
Yeah,
I like the feature, but for a demo, it just takes too long.
No, that's totally. But it's great to know that it's out there because it's such a powerful feature. When you have that issue under production environment, and you have to chase it, and you have to debug it. So it's very powerful that you showed it, I think. What I was wondering myself is there any GDPR risk in exposing those snapshots, because it will snapshot your variables and environments, and maybe there are some personal data in there?
That's a good question, actually. I've never thought about it because you will have the state of the variables. So I can imagine that if there's sensitive information you don't want to store somewhere else, then yeah, you may need to make a conscious decision about if Snapshot Debugger is a right fit for your environment, because because all the other features, for example, within application map, it only show you the metadata, so you won't see the actual information. But with Snapshot, yeah, as the name implies.
Yeah, so it's okay. That's a fair point. Yeah, and I think the retention is limited, right? It's only a couple of 2 weeks or something. It's retained, and then it's just recycled and it's gone. So I always see it's a great alternative for instead of going through all the logs traditionally. Yeah. So that's probably the same question you have to answer. If it's in your logging data, then it can be in your snapshot data as well.
Yeah, same problem. Yeah.
Yeah. Good point. I think I have one last question, Luke, or are there any last-minute questions I missed? I have a question on dashboarding.
No new questions incoming, so fire it.
Then we're just going to do the dashboarding question. Yeah. Because for application insights at the previous company I worked, we had the application data, the application map on a big screen. Which was excellent because you could see your real-time status of your environment very visually. But for my current assignment, we're using Azure DevOps. We're using Azure DevOps dashboarding there. Do you know if there's any way to include the application insights data that is also powerful, that does not have to be the application map, but can we use it on our Azure DevOps dashboarding?
Good question. I've never, I haven't tried it myself, but I know there's a lot of extensions and a lot of APIs you can get from application insights. So I'm not sure. I think we'll need to look into that, and otherwise you'll need to create your own custom extension that gets the data from there. And
that's almost even cooler because we're all software engineers, right? So
we all want to do that.
Cool widget.
Build it ourselves.
Build the features our employers ask for, but build this widget.
Exactly. Why would you use a extension that already exists if you can make your own again?
You're so right. We're just having to search a marketplace.
Because ours is better, right? So yeah,
it's always better, but we need application insights on that as well because it keeps. Right? Okay, well, I think we're through the questions.
Out of questions, yeah. Thanks.
Yeah, well, thank you so much, Yusuf. It was a very nice session. I learned a lot. And I think that is true for everyone. We'll We'll now have a small break, so everyone can do a small bathroom break, get a fresh cup of coffee, or something else to drink, and then we'll resume the session at 8.
At 8.
With 8 p.m. sharp with Stefan and Jordi about Windows Virtual Desktop and also Azure DevOps with image and system management, if I have it correct. But Luke knows it.
It's you're completely right. And otherwise,
it's Windows Virtual Desktop, and we'll see you at 8.
They will correct us when we're back. So
yeah, probably. Yeah. Thank you so much, Yusuf.
Yeah, thanks, guys.
Thanks, Yusuf.
Good luck to the other guys. Bye-bye.
Bye-bye.